Hey guys, it's Monday, 4:28 p.m. on September 2nd, 2019. And I want to try something a little different today. I want to show you some benchmarks here of how the storm is actually taking shape. And I'm going to lay out this argument for you by showing you the wind speed instruments and the buoys without actually telling you what the National Hurricane Center is reporting. Because I find a fascinating inversion here, and I think the best way for me to make my point is just to show you what I see. Okay, so this morning we had this from the National Hurricane Center. This guy live streamed from the National Hurricane Center 7 hours ago. 7 hours ago would have been like, I don't know what, 10 o'clock in the morning. And I want you to look here at the shape of the storm. This entire storm here is just the green area. The blue area is clouds, but it doesn't have any rain to it. The yellow are rain bands. Red and yellow are going to be the rain bands. But these are like actual clouds. Usually when we see a full-blown hurricane, this whole thing is going to be, you know, it's this. This is what we would expect to see with a full hurricane. Of course, these are CGI images, so these are of no avail to us because these are computer generated. But this is actually a radar. It's interesting. It's the same radar that I'm going to use here, and I'll point out a couple things. What he's doing is he is just using he's just showing the southern tip of Florida. But I want to point out that this storm only has half of a storm here. The entire eastern hemisphere of the storm is not existent yet. And if you go back over my old videos, what you'll see is this always happens. This always happens where there's a western hemisphere of a storm that over time takes on this shape. It develops an eye, and it still takes a while to get a full eastern western hemisphere circle going. I shouldn't use sphere, but you know what I'm saying, like the full circle going. And I want you to notice that's exactly what happens here, because here we are now hours later, and I'm going to zoom in here on the storm, and as you can see, this thing is really taking a full shape now. Look at this. I'm going to zoom in even more. See? Look at that. You got a full shape here, guys. This thing is almost completely filled in to the eastern portion of the storm. Another thing I'm going to point out is that in this video, this guy talks about these rain bands down here in the southern part of Florida. So let me play this. I'm going to pull out my microphone here. We're going to do this real time, so I'm not editing this video. I want you to listen to what he talks about with these rain bands, how these rain bands are associated with this storm. And then I'm going to ask like a basic question. Well, yeah, let's just play what he has to say here.
Rain bands stretch into Florida, getting some reports to 40 to 50 mile an hour gusts in some of those rain bands. That's Lake Okeechobee right there. That's the Florida coast. So starting to see some of these rain bands already. So that's one thing to note. A lot of wind in those rain bands. Here's something else. You know, we talk about away from the storm. How many times we talk about, you know, the impacts well away from the storm, Dennis. But look at some of this rain associated with the hurricane over the Keys. And we're going to have to really watch these type of areas because notice it doesn't move much. So
okay, so he's talking about, hang in there. Okay, so he's talking about the rain associated with the storm. You guys, he's only zoomed in on the southern part of Florida here. I want you to notice the rain bands that are associated with the storm stretch all the way up to North Carolina. I think that might be something that you might want to pay attention to, dude. How come he's not talking about the rain bands that are literally growing before our very eyes that stretch all the way up to North Carolina? I think this is a serious omission on the part of the National Hurricane Center. Another thing I want to point out, this is just an oddity that I find all over our national radar here, are these strange little laser straight rain bands. They reflect as rain bands on our thing, and you have this right angle here. What is going on here? What is this? What are these? We get these straight rain bands, and they're everywhere. We have one in Michigan. It looks like a seatbelt on Michigan. We have one in Texas. We have them in Nevada. We have them down here in California. They're everywhere. Nebraska. These are just crazy things, but there's definitely one brewing here. So basically the reason I want to point this stuff out, you guys, is because I'm saying that the information that we're actually able to observe versus the information that we're told. What we're able to observe, and I'm going to show you here in a second with the wind speed instruments, is that there's a storm that's taking shape. So if you look back at what it was several hours ago, okay, here's the storm. Here's the storm. Several hours ago, it was super, super small, okay? Now look how big it is. It's taken a full, robust, round shape. So we're literally seeing, over the last 7 hours, we have seen this storm become a full-blown rain band all the way up to North Carolina storm, all right? Now let's go through what we see with the wind speed instruments. I want to take you to where we looked at yesterday, was Marsh Harbor Airport. Now let's look. I'm just going to show you these data plots as I zoom in here. I have charted the location of this storm according to what the National Hurricane Center has told us. All right. This is what's fascinating, is that this storm hasn't moved hardly anywhere. So since the hurricane wind speeds are supposed to extend outward from 45 miles from the eye of the hurricane, and these are the locations of the eye of the hurricane, we can pretty much use the same places that we used yesterday to track the storm. I mean, we should see high readings of wind speeds, more particularly at Freeport, but still where we were yesterday. And let me point out where we were yesterday. We were here at the Treasure Cay Airport. We were here at the Marsh Harbor Airport. The only one that's really fully out of the scope of the 45 miles for hurricane wind speeds is this Marsh Harbor. Okay, but let me remind you what we found yesterday. As this hurricane, alleged hurricane, went straight through these areas, we didn't have a reading over 21 miles an hour at Marsh Harbor. Same thing at this Treasure Cay. We haven't had anything even close to wind speeds over 40 miles an hour at any of these areas, let alone 185, okay? Wasn't on, they weren't there, okay? Strangely enough, today, you guys, we have wind speeds double what we saw yesterday. So Marsh Harbor, 40 miles an hour, gusts up to 59. Okay, this was updated 26 minutes ago. What we have at this airport here is 28 miles an hour. This is in the Bahamas. I don't know exactly where that one is. Freeport, Bahamas. Wind speed. Now this, it should be very troubling to people. If we're... This hurricane is supposed to be right outside of Freeport. Okay, like, let me see how far away it is. 25 miles away. Okay, we should be seeing hurricane strength winds here at Freeport. But what are we seeing? We're seeing 16 miles an hour, 33 miles an hour. And we're going to go here to the Cay Harbor, or Great Harbor Cay, 33 miles an hour. These are stronger than the winds we saw yesterday. We're going to go to this personal weather station. Now, this one is at the Queens Highway, which is close to Freeport. And I want to show you how from September 1st, which was yesterday, show you how these wind speeds increased over the course of the day and how they got, I didn't pay much attention to this one yesterday, but I think it's pretty interesting. We've got 21 miles an hour as the day progressed, okay? And then I think we see some close to, yeah, here are in the 30s at 6 o'clock. Keep going, 10 o'clock, 38 miles an hour, 39 miles an hour. So as the night progressed, the storm got stronger and stronger. 46 miles an hour, 41, 32, 59 miles an hour, almost midnight, 47 miles an hour. These are very strong winds as it approaches Freeport. Okay, so in other words, what I'm trying to show you guys is that this storm took shape yesterday. So it's not that these wind speed instruments aren't picking up winds. They are definitely picking up winds. They're just showing you a trend that's not consistent with what the National Hurricane Center is showing you. Now let me see if I can get this history for today. I don't know if it's available. Oh, good. Oh, good. So after midnight, the wind speeds pick up to 51 miles an hour, 54. These winds get up pretty high, but they start to hear 66 miles an hour. We're getting wind speeds that are approaching hurricane strength here. But that was at what time? 3 o'clock in the morning. So at night, last night, this storm got really strong outside of Freeport. It's not hurricane strength yet, though. Notice it's not hurricane strength right here, right outside of Freeport. And then it dropped down again. And it dropped down. It got to 30 miles an hour, then 54 miles an hour. So it looks like somebody's trying to make a hurricane happen, and it's not happening. The wind speeds are increasing, but not to hurricane strength winds. All right. And now I'm not saying that anybody's actually making a hurricane. I'm just saying that it looks like this hurricane is trying to become a hurricane, and it's not exactly happening. So here we are now at the Marsh Harbor Airport again, and we can see that these are only going to 39 miles an hour. But that's still almost double to what it was yesterday. Now, here's the thing I find fascinating. What we're actually measuring and what we can actually see. Okay, guys, we can actually see that the storm is strengthening. You can physically, visibly see on this radar that this storm is getting fatter and thicker, and that these rain bands stretch all the way up to North Carolina from the south part of Florida. We can see the storm is getting tighter and bigger, right? Okay, and I just showed you. You can physically measure, even here at the buoys. Look what we have to measure at the buoys. I'm going to refresh this page. At the buoys, what do we have? We have 45 knots. Let's go to my little converter here. 45 knots, 51 miles an hour. Those are wind speeds we did not see yesterday. Okay? 45 knots, 44 knots, 46 knots, 49 knots. We can see, you guys, a storm is taking shape. The wind speeds from yesterday are increasing. The visual of the storm is getting tighter and thicker. Now, I want to take a comparison here to what the National Hurricane Center is reporting. Okay, as of 8 o'clock in the morning, the National Hurricane Center said that the wind speeds were 165 miles an hour. 8 o'clock in the morning. 11 o'clock in the morning, they dropped it to 155 miles an hour. 2 o'clock, they dropped it to 150 miles an hour. You guys, the information that the National Hurricane Center is reporting is inversely related to the strength of the storm that we're actually observing. This is a fascinating point. I want you to listen carefully to what I'm telling you. As this storm is physically growing, when I say physically growing, I mean we can actually measure it here, and we can measure it at all these places. So as we're finally getting a real storm that we can really measure, okay, as the storm is actually growing, the National Hurricane Center is altering their reporting to decrease the strength of the storm. And what we have seen in my videos historically, over and over and over again, is that the National Hurricane Center will decrease their numbers. The actual strength of the storm will increase until those two numbers intersect. How is that happening? I want you guys to think that through. I have some suspicions. I'm not gonna play that out for you. I'll ask you a question at the end of this video. But in the meantime, let's just finish off what this guy is saying here. I want to point out what he has to say, because I think, there's stuff worth noticing here. Let me just play this, and then I'll point you to a couple of other videos I want you to watch.
Just a very dangerous situation for the Bahamas. The other thing to look at, already starting to see some of these rain bands stretch into Florida, getting some reports to 40 to 50 mile an hour gusts in some of those rain bands. That's Lake Okeechobee right there. That's the Florida coast. So starting to see some of these rain bands already. So that's one thing to note. A lot of wind in those rain bands. Here's something else. We talk about away from the storm. How many times we talk about the impacts well away from the storm, Dennis? But look at some of this rain associated with the hurricane over the Keys. And we're going to have to really watch these type of areas, because notice it doesn't move much. So places can get prolonged amounts of rainfall. So as we eventually move this storm to the north, we'll have to really watch where some of these rain bands set up.
Wait, what did he say?
So as we eventually move this storm to the north, we'll have to really watch where some of these rain bands set up, because that could...
One more time.
As we eventually move this storm to the north, we'll have to really watch where some of these rain bands set up, because... Interesting.
So 7 hours ago, he said, as we move this storm to the north, we're going to have to watch for some of these rain bands being set up. Oh, exactly like what we've observed. 100% consistent with what we've actually observed. As we moved this storm to the north, which is exactly what happened, we'll have to watch for some of these rain bands being set up. That's precision right there. All right. So that is my analysis there, and a lot of people have asked me what I think about this. I don't want to speculate about a lot of the stuff because, you guys, I think that you would have to be a conspiracy theorist to think that this data all matches from all these independent places. I think that if you look at this information and see that the wind speeds at this particular airport and this particular area and all these buoys and all this information is consistent, I think you would have to be a nut conspiracy theorist to say that all of this stuff has been coordinated and you know, that this is all just some big lie, that all these data points are a big fat lie. But the National Hurricane Center is telling the truth. I really do. I mean, I think if you guys are, not my audience, of course, but there are a lot of people out there that are like, well, why would the National Hurricane Center lie? Look, I'm not saying they're lying. I'm just saying that it's the National Hurricane Center against all of these other consistent metrics, okay? There's, you know, and here's the problem, you guys, for it's not actually a problem, this is actually a blessing. Here's the blessing, is that the National Oceanic Atmospheric Administrator's Office has to use this data to get ships from point A to point B. This is just a data feed. Okay, this is just raw information. This is not shaped into some, you know, prepackaged, you know, forecast. This is what is actually being read at the moment at those places. Well, same with this stuff. You know, this was updated 38 minutes ago, 42 miles an hour, 59 wind speed. This was updated 2 hours ago, 28 miles an hour, 39. These are just data points that are, available to us. All right. This is a report. This is not associated with any instruments. This is not coming from something that claims to be an instrument. This is coming from forecaster Brown/Brennan at 11 a.m. These guys could put in their mother's cookie recipe. All right, they can put whatever they want in here. You're not going to get their mother's cookie recipe coming from this. This only gives you wind speed information at that particular location of at this longitude and latitude where this buoy is set up. Okay, you see what I'm laying down here? Now another thing I want to, I'm going to leave you a link to this in the description. I want you to go watch this video of a call for an uprising. What he does is he goes through and he shows some history of some of the public appropriations committee testimony of, I think even there's something from Kennedy or maybe Eisenhower, one of the presidents, I don't know, but there are a couple of these videos out there where it just talks about, it's not been a hidden thing that the United States has wanted and has used weather in warfare before. Now, before you can go using weather for warfare, don't you have to test out the instruments? I mean, where would the United States, if we wanted to use weather manipulation as part of our warfare in our military, where would we practice that? You think we'd go to Antarctica? It'd be kind of hard to manipulate the weather in Antarctica. How well do you think Russians would appreciate us testing out our Boeing equipment or our, Northrop Grumman military technology in Russia? You think we test it out in China? When we have cannons and we have guns and we have, different sound cannons and things like that, we test those things out in all sorts of different military testing sites. What do you think? How do you think they would test that kind of equipment and where? So I'm just asking questions because I think that might explain, if you think about the answers to those questions, it might explain why we're getting one set of information from the National Hurricane Center after the repeal of the Smith-Mundt Act versus what we can actually measure by the instrumentation that they can't afford to take down. You cannot take down this information. You can conceal it, you can edit it after you go through the history, you can scrub it, but this is real-time data, and there are ships in the ocean that are actually using this information to navigate from point A to point B. Okay, these are raw data feeds. The Federal Aviation, the International Aviation organizations, they actually use these raw data fields. So when we're at an airport, an international airport, you know, this some of them are down, some of them are used for private information, but you know, this information is it's pretty common. It's necessary for navigation. So anyway, I just thought I would point these things out, and I hope you guys have a good day. I will keep you posted on my observations. Have a good day.